Hi, I'm Marty Kelsey, and welcome to the Air and Space Live Chat. Today's topic is teacher professional development. I was a teacher for 17 years before coming to the National Air and Space Museum, where now I'm one of the hosts of STEM in 30, an Emmy-nominated show produced for students by the Air and Space Museum. And we got 2 new nominations last night, so keep your fingers crossed for us that we can bring home a win this year. Our most recent episode of STEM in 30 is all about careers and takes a deep dive look at them. It includes some amazing people and has some things that you can use in your classroom. Throughout the program today, we want to hear from you. Not only let us know what questions you have, but also let us know where you're watching from. We'll be giving shout outs, and if you're in a classroom or you're a teacher and you're in a classroom, let us know what school you're teaching from. Now, if you've tuned in before, today's show is a bit different because we are focusing heavily on teacher professional development. But if you're a student, a parent, or just someone who likes cool stuff, stick around because we will be taking questions and we're going to be going over some really neat things today. And that's where you come in. We want as many questions as we can for our panelists, and we'll get to as many of those as we can. We will be talking to members of the Teacher Innovator Institute today, and we'll be learning more about that. We also have some teachers monitoring the chat, so if you've got some questions, put them in the Facebook comments, and we'll get to as many of those that way as well. I'd now like to introduce Shannon Baldioli, the Educator Engagement Specialist at the National Air and Space Museum. Hi, Shannon.
Hey, thanks, Marty. So I work with a ton of teachers as the coordinator of the Teacher Innovator Institute, and I'm really excited to talk a little bit about how the STEM teachers that I work with put that art in there and make it STEAM.
So Shannon, today we're talking about interpreting the sky through art and science, and that seems a bit daunting. What does that mean?
So we're going to talk a lot about science and different ways you can document science with art. We'll talk a little bit about interpreting the sky and some other scientific projects that our teachers are working on. And we're going to dive into 3 different ways that you can integrate art into your STEM classroom. Now, we're going to focus a lot on visual art today, but there's tons of other examples of music and poetry and dance, other forms of artistic expression inspired by science. So if you're using any of those, please feel free to tell us about it in the comments. So that first way is pretty obvious, documenting the world artistically. Marty, I know you like to go outside at night and take pictures of the International Space Station and stars. So you can just document the natural world artistically with a pen and paper, with paint, a camera, or my absolute favorite one, if you've never seen the glass flowers at the Harvard Museum of Natural History, the glass flowers were actually created to sort of show people what the anatomy of a flower looks like, but they look like sculptures. It's incredible to think that they're made out of glass.
Those are amazing.
Yeah, so cool. Our second way of interpreting science through art is by visualizing data. And I'm not going to talk a ton about it because we have an awesome teacher and a fantastic educator from the Air and Space Museum. They're going to talk a little bit about what data means, especially data from topographic maps or from space telescopes. And then we're going to briefly touch on art that's inspired by science. And this is pretty cool. So 20th century artists like Robert Rauschenberg, Isamu Noguchi, and Alma Thomas all were inspired by the moon when they created some of their iconic works, which actually are in the Smithsonian's collection. And we're lucky enough that our Smithsonian next door neighbor, who's the Hirshhorn Museum and Sculpture Garden, has put together a whole bunch of projects that you can work on at home. If you're a family, you can work on them as a family. Teachers, you can work on them with your students. It's called Hirshhorn Kids at Home. So Kids at Home has a website, and then they also have a Smithsonian Learning Lab for teachers that are looking for step-by-steps. And there's lots of different projects based on art in the Hirshhorn's collection, but they actually created one for us called Over the Moon. So this was a project developed based on Robert Rauschenberg, who was an artist that made prints. And he spent weeks at Cape Canaveral before the Apollo 11 launch, learning all about the astronauts, the Apollo missions and the moon. And he created the Stoned Moon series, which is 30 different prints that sort of explore that time in history.
Awesome. Well, if you are a teacher or have teacher friends, be sure to give this video a share so that they can see it, even if they can't tune in live. That way they'll be able to see it after the fact. Shannon, thank you so much. We're going to bring you back in a bit later to answer some questions. But right now, I'd like to introduce Shauna Edson, astronomy educator extraordinaire. And Shauna's going to talk a little bit about data visualization. Shauna?
Hey, yes. So data visualization through the eyes of astronomical and Hubble telescope type images is something I really love. And I have one of my favorite examples, which is the Crab Nebula. So this is a nebula. It's an exploded star. This is the guts of a star that blew up. And I love having people look at this and just think about, what do you notice? What do you see? It's a picture. There's color. There are shapes. And like I said, this is an exploded star. But at its core, this is data. This is light that was collected by several different space telescopes and recorded. So like all images really are data about what light, how much brightness, and what colors were coming from what parts of the scene. And so astronomical images are data visualization, and we use colors to help us show information and patterns and learn more about what we're seeing. When you see an image like this that's so saturated, a lot of people will ask me, are the colors real? And this is debated a lot in astronomy, but the light, the observation, the data is real. And telescopes like this image is multiple different telescopes looking at kinds of light that not all of them are kinds of light our eyes can see. So this isn't what you would see if you looked into a backyard telescope, but it's all real light, and we use color. We assign colors to different parts of the image or different kinds of light. And that data visualization using color allows us to notice things that we otherwise would not. So there's multiple things going on in this image. The different colors are different observations. So the colors themselves may not be what we would really see, but the information is real. And to show another example of that, I have another nebula image. This one is the Cat's Eye Nebula. And this is two different views of the same thing. So you've probably already noticed there's some patterns and shapes that are similar between these two. These two images were both taken in visible light. So not getting into X-ray or infrared, things that our eyes can't see. This is all light our eyes could see. But it's being shown, the data is being visualized two different ways. The one on the left is what we would call natural color. So it's much closer to what our eyes would see if we were looking at this up close. The one on the right is enhanced color. So it's the same visible light, but this time the scientists have assigned colors to the different gases. So where you see red is where there is hydrogen, where you see green is nitrogen, and blue is oxygen. So as you look at that, it goes from just being a pretty picture with colors to a lot of information. Okay, the hydrogen is here, the nitrogen is sort of on these edges. It helps us piece together what happened when this star exploded, how long it took, and it even lets us know what temperatures or conditions are like in this exploded star. And that is all by using colors to visualize the data in order to understand it better.
Shauna, that's awesome. And you're talking about the Cat's Eye Nebula. Do you have a friend with you still?
My cat is no longer sitting on my lap, but I'm sure she will make an appearance.
A couple of minutes before the program started, Shauna's cat climbed up on her lap and was making an appearance. So we'll see if we see the cat here in a little bit. We've got Derry, Northern Ireland, Herndon, Virginia, and Manchester in the United Kingdom all tuning in. Let us know where you're watching from. We'd love to give shout outs throughout the show. Also, there is at least one eagle-eyed viewer that has noticed something today, and bonus points for them. So keep up that good work. Now I'd like to bring in David Black, a 7 through 12 science and tech teacher in Orem, Utah. David, how are you doing today?
I'm doing well, thank you.
All right, so David, you do some of this stuff in your classroom. Can you tell us about that?
Well, one of the things I try to teach my students is how to use authentic data, and there are a lot of different data sets available out there. So I tend to use NASA data. Some of it, of course, is available as photographs, but those photographs can be at different wavelengths, like Shauna mentioned. So you can find like WISE data, which is infrared, and you can combine it with X-ray and other types of frequencies. And what I have my students do is take Photoshop and then bring in these different images as different channels, the red, green, and blue channel, and then you get what's called a representative color image. But one of the things I've worked on the most is trying to see if I can get 3D altitude data of the planets available, turn it into a model that I can then print out through my 3D printer. And so I'd like to kind of work you through a little bit of the process here. So let's begin with just data from Earth. So of course we've had different different missions who have collected data from the Earth. Probably the best one is the Shuttle Radar Topography mission. And it has data from about 55 degrees north to 55 degrees south latitude. And it's very highly detailed. And you can actually download it from what's called the Earth Explorer website from the U.S. Geological Survey. So let's go back to that slide for a sec. And what you do is inside Earth Explorer, it's very easy to use. You just specify what the object is by name, or if you know its latitude and longitude, you can look that up. Specify how big of a radius to look for. And then you click on results, and you get a list of different types of data that you can look at. This includes geological information system data, GIS data. But I'm after the 3D altitude data, which is listed as, DEMs, basically, digital elevation models. And the best data is the SRTM, the Shuttle Radar Topography Mission data. And I go for the most detailed, which is the 1 arc second. And so choosing that, you get the results. And what it comes out as is a grayscale picture, right? And so the lighter areas represent higher elevations and the darker areas represent lower elevations. And
I really love in your example here how there's the flat image and then you have next to it the 3 dimensions. So right. There's what your light and dark data is telling you it's actually shaped like. That's beautiful.
So on the right, you actually see part of the Grand Canyon, with the Kaibab Plateau being the high area to the north. That's the north rim of the Grand Canyon. And then you see how that information, once I bring it into a program that can read it, in this case, Adobe Photoshop, the newer versions have 3D features. It will actually turn the grayscale image into a 3D model. And on the left, that's actually the area where I live. This is Utah Valley. I live right along the Wasatch Front, which is a high range of mountains, and you can see Heber Valley and Park City kind of behind the mountains there. And then that's what the model looks like on the right. So next slide. So here's another part of Utah called the Book Cliffs. And if you're into geology or landforms and you teach anything along the lines of earth science, this is a really cool feature. It's called a geosyncline, where a huge bulge came up and then kind of the center of that bulge eroded away, leaving this rim of mountains along the outside. And the layers here were laid down during the Jurassic period. And so this was an inland sea that had all this clay and mud deposited, and dinosaurs walked along the edge of it. And so in those swamps along the edges of this inland sea, there was a lot of coal that was deposited. And so now, right along that arc that you see of mountains, those are called the Book Cliffs. There are coal mines all along the bottom of that layer. And the interesting thing, when they go in there, they find dinosaur footprints on the ceiling, because they're digging out the coal from underneath where the dinosaurs walked. And they have to be careful and bring the dinosaur footprints down, or else it could fall on your head. And they're big. But you see here a 3D model on the right where I had an altitude-sensitive texture put on it, so you can see it. And that's pretty close to being, the real elevations. But you can see that kind of gash of a canyon on the right side. That's the Green River. And the students at my school were just there at the mouth of the Green River doing river running earlier this week. So that's one of the reasons I made this model, to show them where they were going.
And David, what I love is that you're connecting, this data visualization to what's happening to them and where they live. And the other thing that I think is really cool about this is, Shauna was talking about images from space, stuff that's way far out, and you're looking at it right at home, literally right at home. And I think it's really neat to see that data visualization works not only for the stuff that's way out and the stuff that's up close, but the one question that I have for both of you, this seems really hard. Like y'all make it seem like you're talking about like it's super simple. Can a normal teacher implement this in their classroom?
Oh, sure, absolutely. This is not very hard to do. I mean, you have to know where to find the data. But the Earth Explorer website is very easy to use. Once you get a grayscale image, almost any 3D software can read the grayscale image and make a terrain out of it. There's even some free software available online that can modify these models. That's browser-based. And so you don't have to put out a whole lot of money to do this. And I've had students as young as 6th grade do this without any problem. So I teach this quite frequently in my classes.
That is awesome. And I love the free part. Go ahead, Shauna.
Yeah, well, and a great concept that both of David's images were showing is that the data and all these complexities and things feel like a lot. But if we boil it down, especially with terrain modeling, and I have a geology background, so I love this, what it boils down to is you have a 2-dimensional map that's representing a 3-dimensional structure. And the landforms and shapes, like what David was showing, tell us the story of what happened. So we see hills and mountains and valleys around us, but they really are telling the story of what has happened to this part of the earth. So the geosyncline he was talking about, by looking at that rim of mountains and that gorge where the river goes and the flat area in the middle, just by the shape of the land, which we can understand and visualize from that elevation data, that allows us to then piece together what happened here, what kind of rocks are there, what processes shaped this, and allow us to do things like find where the coal would be or see where the river has eroded. So the data feels kind of abstract, but when you visualize it, you can make it concrete and real, and it becomes something that your brain can find patterns within and interpret and make useful information out of.
Awesome.
That's one of the reasons that I do this, is that, most of the human brain is geared towards visual information, right? And so I don't know about you, but if I see like a big table of numbers, I have a hard time understanding it. But if I can take those numbers and put it into some kind of a 3D image, then I can see all kinds of patterns. So here, for example, are some models of Mars that I did.
I love these.
So we go back to the previous slide for just a second. For finding the data for Mars, this was something that took me a while to figure out, and I did a lot of searching and finally found a person named Kees Wienenbos who was doing this in the Netherlands, who gave me some tips. And I'd seen his work. He did some covers of on the National Geographic magazine of what Mars looked like billions of years ago when it had water. And he was really kind to kind of walk me through the process. Well, the data is available for free. That's an important thing. When NASA does any kind of space probe mission, the principal investigator has dibs on the data for 6 months to a year. But after that, they have to put it up on the internet where it's available for anyone. The trick is knowing where to find it and how to use it.
And David, we will put some of the links in the chat. And I hate to wrap this up here, but we need to move on. If you've got questions for David and Shauna, put those in the comments section. We'll be bringing them back in here in just a few minutes. And again, let us know what questions you have for all of our teachers today and where you're watching from. We've got Anchorage, Alaska, Quincy, Illinois, and White Plains, New York, all tuning in. Thank you all so much. Let us know where you're watching from and what questions you have. And now I'm excited to bring in 3 more teachers. We've got Jessica Sadler, a middle school science and STEAM facilitator near my hometown. She's in Lawrence, Kansas. We've got Marika Fagan, a K-5 art teacher, and Kelsey Volmer, a K-5 science teacher, both of them from Seattle, Washington. Thank you all so much for joining us today.
Yes.
Thank you.
Right, so Jessica, I'm going to start with you. Tell us what this looks like in your classroom.
Sounds great. So I teach middle school science, but have been doing work the last several years on arts integration with some of the local groups. The Kennedy Partners and one of the local colleges have some things, partnerships with the museum, really just anything to get my hands on integrating some more opportunities. So I did put up some pictures of various projects that we have done. The first one that we're going to look at is a lesson that was created. Yes, this one right here. So the students start out and I give them very traditional character looking stars that are real stars with an appropriate coloring. And I give them to groups and I say, hey, organize these the best way that you see fit. And you get various things, then the students go around and they have to make observations about how other groups sorted. Some do it by color, size, alphabetizing names. It really just varies. And then we talk a little bit about HR diagrams and how stars are plotted and manifest in real life and how we identify and study them. And then something that we do, you'll see the card that's on the right, the gold statue looking piece. Those are some what are called art cards or collection cards from one of the local museums. You can find them online if you don't happen to be located in Kansas. And then I actually have the students plot art based on the luminosity and the other characteristics that how we would plot stars. So I make a big HR diagram that hangs on the board, and then they have to evaluate their piece of art. Do I think this has a luster? Would I consider it a high luster or not? So they are basically using these alternate terms for luminosity. It really challenges them as well because they struggle with the color concept and the idea that typically we think of the reds and orange like as the most hot things. And so you'll have them go up and they really sit there and they're bright. Like you can genuinely see them thinking about it. Moving on to the next slide, this is a project that we'll be doing. So this is actually off the Smithsonian's website, and students practice their micro pipetting skills with diatom art. So it is a Victorian idea of a fairly not incredibly practiced anymore art form because it's microscopic, and I can't imagine putting in so much effort for something that would have to be looked at under a microscope. But we talk with the students about the idea that diatoms are considered one of your largest primary producers of oxygen on our planet, and the way that they look, and they have such a various structure and coloring and all these different things. And so we integrate these pieces of art into students practicing their micropipetting or general pipetting skills, and they actually create their own pieces of art, not at the microscopic level, but they turn out quite wonderful. And then if they've done it with a decent amount of spacing, we can also do usually an overlay and capture their art onto something that they're able to keep with them.
Hey, Jessica, before we move on to the next one,
yes,
take a breath. We've got time, and we want to make sure that we understand what you're saying, because this is some incredible stuff. And I love that the lines are being blurred between science and art and back and forth. This is some great stuff that you're talking about. So we want to make sure that we get
I'm a naturally fast talker, and I don't want to hog all the time. So
I would guess that all four of the people you see on the screen here are all naturally fast talkers, because typically you have 50 minutes and you've got 75 minutes worth of stuff to cram in there.
Yes.
So go ahead, Jessica.
Excellent. Thank you so much. Advancing to the next slide, this is a very wonderful opportunity. So coolscience.net, they are a partnership between UMass Boston, UMass Lowell, the Massachusetts College of Arts and Design, the University of Kansas, and then the Kansas City Arts Institute. So this program has been going for several years. They just opened it up to the Kansas City metro area last year, but it is a free arts and science contest. And so they pick 3 overarching questions for the contest year. And then students create an artwork that conveys that scientific research that they've done on the topic. So this student and I tackled this last year. And when I say I was very loosely involved. So she took on the idea of having this topic for how animals naturally have abilities to keep themselves cool in hotter summer months. The contest requires ideally limited text, and then they take the honorees and they put their artwork on your local transit lines. The student that I worked with, she actually ended up winning for our area, and then returned to the competition this year and successfully completed and won again. So she's feeling incredibly proud of herself. This year, the topic, it typically always focuses on extreme weather. So she is doing thunderstorms and how they manifest, and then what happens to them when they're just all of a sudden gone. Where does that energy go, and how does that work? Extremely, extremely cool thing. If you're within the area, I strongly encourage looking into it. And then my last 3 slides are all related to the same thing, and it's a little bit more in the visual. This is how I typically go about teaching vocabulary with an arts concept to it. So this was before we started our Earth and Space, more astronomy-based things, and I give them the words, and then they have to come up with their idea of what would model that effectively. And we talk a lot about the 5 different concepts, and we have motions that go with it. So we're thinking about color, we're thinking about size, your spacing, line, and we talk about all of those things and how that can add to your meaning. And then they get these very small, they're only about 1 inch by inch, so that way it's not too overwhelming to be like, I have to fill all this space. And they go in and they come up with visuals that would enhance their vocabulary and their understanding. And again, this work is coming from my 6th grade students. So, I mean, it's 11 and 12-year-old ability, and it's pretty great. If you'll advance to the next one, I highlighted a couple more closely. This down where you can see the pencil, it's the yellow one and the image on the left. That student actually laid their mechanical pencil within the box, and the writing that you can't see, they've modeled that this is a to-scale model, which was one of their words. And so you get a lot of very unique ideas and ways that they are bringing this into their understanding, and it turns out super, super, super neat. The last one, if you'll yes, this one. I loved this one. Their word was illuminate. And so we had kids being like, Illuminati. And I'm like, no, illuminate. And so that, and essence changes a lot of the definitions and pictures that they will draw. And I loved this student, how it was in the dark, and then when the illumination happens, now you can see that there's a cat or animal, Sean, I'm sure will appreciate that has now shown up in this image, and you can get a really clear idea of truly what they are or not understanding. So this is how we do a lot of our vocabulary.
I love it. And I love what you said about really being able to see their understanding there. And I see Marika nodding and smiling as you were going through this. Real quickly, we have the Ukraine tuning in, as well as Indiana Academy in Muncie, Indiana. Thank you all so much for watching. Let us know what questions you have in the comments. We'll be getting to those here in just a little bit. But Marika, how do you bring science into your art classroom?
Oh, goodness. Well, first of all, those were amazing. I am excited to actually get a hold of some sheets and try that with our younger kiddos. But I am lucky enough to work with Kelsey, who's just an amazing science teacher. And we've just really found a lot of great ways to come together, especially around when we do space. Kelsey does a space unit with our first graders. And so actually it was my first year at Meridian when she came to me and said, hey, I think we can do a combination here with science and art. And this was actually the second year we did it. The first year we made good old paper mache planets with our first graders. There was a day where I thought I would get fired if anybody walked in the room because it was insane. But
good teachers have all had those days.
Yes. So since then we've kind of changed it up every year. The second year was the ones we just had on the screen. Those were marbleized paper planets that we made. You can see them up in the corner there before they made their way to the board. We also had the kids splatter paint the background. I mean, they really put the whole thing together. And then you can also see the booklets that they made with Kelsey that we put along on there. And then the third year that you were just on a second ago was we switched to moon phases. So these were mosaic moon phases that we made with our first graders a few years ago. We did two versions. We have two classes for every grade level. So each class made their own set, and we had them in two separate areas of the building. And we obviously had to pair up kids. So each moon phase had, I think, two, maybe three for a few of them, kids attached to it. And they studied their phase first, obviously. And talked about it as a group before we went on to the art portion of it.
Awesome. And Kelsey, how has the learning improved in your classroom because of the art collaboration?
Oh, yeah, definitely has improved. One of the great things about collaboration is we can integrate the things into even more subjects. So with science, it's really great if you can integrate it with the social studies that kids are learning or their writing unit. So a lot of times, I work with the lead teachers of the classrooms as well, and we integrate the reading and writing so that it focuses on whatever we're learning in science. And then when you put art into that and give kids even more of that hands-on and give them a chance to visually represent their knowledge, it just takes their learning to the next level, which is always really awesome.
I love seeing all of the images of the projects that you all are working on. And as you go through that, are the kids hesitant at all at the beginning when you try to take the art or the science and put the art in it, or the art into the science?
Definitely.
Yeah, I would also say though, I think it opens it up. So for students who really love art, but maybe are a little bit more intimidated by science, they have a connection that they can really bring and connect to, and show their talent and show their learning through their talent. And same thing with science. So a lot of times, we have kids who maybe aren't as good with the art, but they're really good at the science. And so I think it helps to actually bridge that disconnect of like, well, I'm not good at science or I'm not good at art. And they can see like, oh, I can integrate them and really show my strengths and also practice this other subject.
I love that, connecting what they're strong with to help them with what they're not as strong with. That's absolutely amazing. All right, well, we've got a former TII participant in Kelsey's cohort. Trevor is watching. Hi, Trevor. Thanks for tuning in. And we've got a few questions coming in that we're going to get to here in just a minute. Right now, I want to show you all a video about the intersection of art and science. It's from our episode that we did on exoplanets. And we talked about exoplanet art and how you can do this at home. So check it out.
Art is for everyone, and the only limit is your own imagination. This especially goes for exoplanet art. We can't see these faraway planets in great detail, so we have to use our imagination when considering what they might look like. The authors of the book Exoplanets explain that there are a lot of exoplanets, and there is no wrong way to imagine what they may be like.
The astronomy community is discovering planets outside of our solar system at the rate of about 1 per day. And if you use that rate and see how many planets are around our nearby stars, we suspect that there are more planets in the observable universe than the combined number of heartbeats of all the people that have ever lived on Earth.
We figure that if you can imagine any exoplanet, provided it doesn't violate some law of physics, it probably exists somewhere.
You can create your own exoplanet art using some simple materials. Start with a poster board and just a few colors of spray paint. First, put down the colors of your primary planet, usually 2 or 3 colors, and think about shadows and where the light is coming from. After layering your spray paint, take a plastic bag and lay it over, and pull it up. This creates the planet look. Now cover your planet and paint your sky black. Next, flick white paint over the painting to represent stars. Use a straight edge to spray straight lines. Uncover your planet and voila! An exoplanet! You can always learn additional techniques like comets, foregrounds, and rings.
Exoplanets are not the only inspiration for space art. The Juno mission to Jupiter has inspired some amazing pieces. Scott Bolton, the principal investigator, discusses how science influences art and how art influences science.
And I really believe there's an intersection of art and science which is very important to us all in almost all fields. And here you see a lot of the images, and this is one of them, where somebody posts something that they're inspired in some artistic fashion. There's science in this too. They're taking the swirls and they're showing you in a new way, and that is exactly how science works too. Is I look at a picture from a different way and I all of a sudden see some feature that I wouldn't have otherwise recognized. That's the idea of the original stretch of colors. Mm-hmm. This is more extreme. I'm not sure scientists would do what a lot of the amateurs are doing, but they are going to start now because we're learning so much from it. But it's also just a beautiful picture.
No matter what your medium or your inspiration, you too can be an exoplanet artist.
Paint, pencils, Photoshop, or even pancake batter can be the way that you share your imagination with the world.
What far out places will you dream up? What art will you make?
And as you can see, I like making pancake art for the kids on Sunday mornings, and so we got to do a little bit of exoplanet art. So we've got everyone back now, and we've got some questions rolling in here that I want to make sure we get to. First of all, let me say, y'all are awesome. Like, watching you all and what's going on in your classrooms is so cool to see, because I know that you are inspiring so many kids with your enthusiasm. So thank you all for that. And we've got a question that I think is really important that I want to start with, and that is, how do we start? Somebody wants to know, so many times science teachers are driven by curriculum, and it's hard to convince administrations to allow us to innovate. Is there a simple starting spot? Who wants to take that? Kelsey, go for it.
I can say ask. I mean, I kind of, maybe I did this wrong. I didn't go to admin. I went to the art teacher, or I go to the music teacher and just ask, hey, here's what I'm doing. How could I connect this to what you're doing in art or music? How can we maybe bring this together so that students get it in more than one place? I think in the end, it's just so much better for the students when they get the information more than once, and we see a lot more success with them. So ask is a great place to start. Jessica, how about you?
I was going to say I've gotten kind of creative in even how I take my data sampling. So like when we're starting this, instead of something that's more paper pencil based where I'm looking at it and I'm evaluating and grading in that sense, we do things like Tableau where the students will get up and they model it through using their body, and I will take data samples, like, okay, we had 16 groups, 15 of them were successful. With that 16th group, these are the interventions that I put, and assigning kind of like a number to the products, because ultimately that's what administration and leadership like want to talk about when we have some of our meetings. So I can take these art and the integration that we're doing within class and figure out a way to creatively assign a data point to it, so that it's also very discussable to those who might not really understand quite what's going on yet. And it proves the success and validity of doing so. Yeah.
Sometimes you just have to get a little creative within the curriculum. Marika, go ahead.
Yeah, I just wanted to add, I think something Kelsey's been great at as a science person for me is when we've done these big displays of really saying, okay, where are we going to show the learning? And we've created this beautiful display, but where can we show the students learning? And so putting up those packets about space that the students created along with the display, or we've done other things where maybe they're talking about adaptations of animals. So just really making sure that that learning is visible to your administration or your colleagues or anyone else who's walking by and viewing what you're creating with kids, I think is so important.
Shauna, go ahead.
Yeah, and I'm a museum teacher. I'm not a classroom teacher, and I'm in awe of what all of you do in the classroom. But I think in terms of 21st century skills and life skills, once you're done with school, the world is not subdivided into topic areas. Our brains understand the world and knowledge as all integrated. So there isn't really a divide between science and art. They are each ways of understanding one another and all other things. So I don't know if making the case to your administration, if you have to, helps to say, we're teaching students how to integrate different kinds of ideas and think about things in different ways as a way of serving them later in their life.
All right. We've got another question that's come in. What authentic audiences do you all use to showcase your students' work?
Marty, I've got a good one. So we have a colleague that works in Charlottesville in a STEM school, and her students actually created a scale model of the solar system. They used some really exciting things. Each were assigned a planet, and some of them did sort of a recreation of a planet. Others interpreted through mythology and art and other ways. And they displayed them actually in Charlottesville. And so many business owners and so many folks were really excited to see these planets. They've kind of made their way around the community and become kind of a cool community project there. So there's lots of ways you can talk to your community about displaying student work.
Awesome. Jessica, go ahead.
So the school that I teach at sits within the boundaries of 3-ish museums. And last school year we did, during our plate tectonics unit, we had students go through the process of what it's like to create an exhibit, to create their own piece of a larger installation, and then turned the whole classroom into a museum itself, and then had local museum curators, anybody that was able to come actually came in and did a tour and asked the students questions and kind of evaluated their work. It was really cool. The students were over the moon to have them, but it made a really nice experience. So they weren't only getting the science and knowledge there, but they were also kind of getting feedback for how well they had done.
It's fantastic. Do they want to come help design our museum?
Yes.
David, what'd you have?
Well, one of the things I think is really important is getting out to the community what you're doing. And so as part of that, I have a couple of different blog posts that I actually maintain, and I often have my students be like guest hosts. They write up a post that talks about what they're doing in the classroom. We create like a monthly or bi-monthly newsletter on topics of astronomy or science that we send out to the community. And I'm always trying to communicate with parents and say, oh, look at this great thing your student did. So there's a lot of kind of PR about this, but it's important to get what the students are doing, their great work, out into the community. At the end of the year, I have students actually put together what I call a science showcase, and they put on demonstrations. We invite in the community, their siblings, but then we also display up on the walls all of the work that they've been doing during the year. And we get a lot of great feedback for that.
That's awesome. Well, we've got another question that's come in, and it's really interesting because in the last 2 days here at my house and in a meeting we had earlier, we've talked about how the outside expert sometimes is more heard than the person that's normally in the room. And so somebody wants to know, do any of you all bring in professional artists to connect with students for additional perspective? Marika?
I was actually going to say that. Actually, we have an amazing watercolor artist who lives out in Port Townsend, which isn't too far from us here in Seattle. And we have been lucky enough to have her come in for several years now. She normally works with our kindergartners, but Kelsey and I and the kindergarten team have started a nature journaling program here at our school, which is very science and art connected. In fact, here's one of our nature journals. So we all have little great paint kits that she's provided for our kids. And she comes in, like I said, a few times a year and really just really helps expand that whole nature journaling piece for our students. They observe, we have beautiful trees, apple trees all along our property here. So they go out and observe the apple tree, and she talks to them about how to draw that, taking those scientific notes and whatnot as well. So that's been one of our most successful pieces, is to bring in that professional artist to work with our kiddos.
Awesome. I think anytime you can bring somebody in, no matter what the topic, that has a little bit of expertise, it just adds so much to that learning process and what the kids take home from it. Are there any STEAM competitions somewhere where kids can learn science and art with a competitive bent? Anybody know about those?
I think the best place to start is probably personal and local and immediate. So we have an engineering business nearby that does a competition every other year for the Battle of the Brains, and then whatever student group, because it's all across the Kansas City metro, whatever student group wins, they actually bring that group's vision to life in our local Science City Museum at Union Station. And it's incredible. They've been doing it for several years now. They call it the Battle of the Brains. So there are things like that. There are several different kinds of art competitions. The Oak Ridge Institute, they're obviously in Tennessee. They do a lot of monthly things. If you get on their listserv, they send out things that are teacher related, where you can deliver a lesson plan that is a science, arts, integrated STEAM business, but they also house monthly competitions for your students as well. They come up with the topics and then just send you the email, and you can choose to participate that month or not. But they're a really nice resource if you're looking for something, and you don't have to live in Tennessee to participate in that one, but they are very avid in doing so.
Awesome. And if you're watching today and you've got a resource that's your go-to, let us know about it down in the comments section, because I know as a teacher for 17 years, I learned so much from the people that I worked with and that I collaborated with. So please put those in the comments section. We've only got time for about one more question, but I want to bring something back up that Kelsey mentioned earlier. We got a question in. Do you ever encounter students who have been convinced or have convinced themselves that they aren't good at science or good at art or good at whatever? And I see you all nodding, because I think we've all had that. How do you get a student past those initial feelings? Kelsey,
I can start. Yeah, I can start. I think one of the things, I'm really lucky. I actually started teaching science to high schoolers and found that there was a lot of that, I'm not good at this, and they kind of shut off to it. And so I came down to elementary really to kind of to inspire kids that, hey, anybody can access science. You don't have to just have that scientific brain. And I think that's the approach that we try to take here at our school and in my science lab is, how can you make the connection to the students that's more than just, filling out a worksheet or math or whatever they think science really is? How can you make it super hands-on, super collaborative? And one of the things that I really learned from the Teacher Innovator Institute was, a lot of times science programs, especially if you have a curriculum, they're very prescribed. They're very here's your box set of science. And really what kids want to do is they want to be the innovators. So can you take, instead of saying, okay, students, today you're going to build a flashlight to show me that you understand electric circuits, give them a problem and say, hey, the lights have gone out and we need to get home. How are we going to get we need to get around the school. How are we going to do it with no electricity? And so then they just come up themselves and say, oh, let's build a flashlight or let's build a lantern or whatever it might be. So kind of embracing that idea of, I don't have to tell the kids what to do. I can more give them the problem, and they have to be the innovators to figure out, how can I solve this problem? And I think a lot of students can really grasp that much more than this is the right answer and this is the only right answer.
I love it. Jessica, did you have something to add?
Yeah, sometimes I will start by asking the students what it is that they don't care for, because it gives me a starting space and a really good baseline. So as a middle school science teacher and teaching sixth graders, a lot of times I'm my students' first exposure to what we would consider, like they consider real science. So when they have that question and they say, well, I don't like science, it's not fun, I say, well, okay, like what kind of science have you done in the past? And 9 times out of 10, they don't have an answer, or their answer is, oh, well, we read a book about it, or we did this, or something very, something very not necessarily what we are actually going to be doing. And I say, okay, thank you for letting me know. Like, I'll take that into consideration. And then sometimes before we start things, especially if it's something that integrates arts that might not be for everybody, you know, we don't all love music, we don't all love dancing, things like that. I'll say, hey, I know this might not be fun for some of us, but we're all going to try our best, and this is what we're going to do. And just from the original part, kind of acknowledging, hey, I know you think you might not like this, but we're going to still give it a good try, and putting in a variety of different things. Usually by halfway-ish into the year, when you ask kids, hey, are you still like not feeling it? They're like, oh no, this is my favorite class. And it just changes their perspective. But a lot of times it's because of asking that initial question that I better understand how to structure things as their teacher.
And teachers, I will say that your enthusiasm in the classroom is directly related to the enthusiasm of the kids for a topic. You know, when you all are passionate about something, it absolutely comes through. And unfortunately, we are out of time for today. Thank you all so much for this great conversation. If you have questions that we didn't get to, keep putting them in the comments section, and we will go back and respond to those later. If you liked today's show or missed any part of it, you can head over to the STEM in 30 Facebook page or the National Air and Space Museum's YouTube channel to catch the archive. Give those videos a like and a share so that other people can learn about these programs. We also encourage you to check out the newest episode of STEM in 30. This 30-minute show features some amazing people talking about the path they took to their amazing jobs. This includes ABC's chief meteorologist, Ginger Z, founder of First Robotics, Dean Kamen, and a bunch of amazing students, astronauts, engineers, and scientists. And teachers, the show is broken into 3 to 5 minute segments to allow you to customize how you use it in the classroom. It's available right now on the STEM in 30 socials or in the Air and Space YouTube channel. And teachers, we have another great opportunity for you. On June 2nd, we are having an evening conversation with the author of The Martian, Andy Weir. He will be talking about his new book, Project Hail Mary, and a group of teachers will be having a discussion with him about writing science fiction. And I can tell you, I just finished it last night. The main character is a teacher. How cool is that? And if you've enjoyed this program, be sure to give STEM in 30 a follow on Facebook and Twitter. And if you have suggestions, feedback, or ideas, we'd love to hear them. Kick us an email to STEM in30@si.edu. And for all of the teachers watching, we appreciate everything that you are doing in your classrooms. You all are the ones that are inspiring that next generation of explorers. And from everybody at the Air and Space Museum, thank you. Thanks for watching.